Oxidation number is the way we express the number of electrons being lost or gained from an element. Oxidation means loss of electrons, which we remember as oil. Reduction means gain of electrons, which we remember as rig. This gives us the mnemonic oil rig. This reminds us that oxidation is loss and reduction is gain. A redox reaction has both red reduction and oxidation. For example, in the following reaction between magnesium and copper chloride, magnesium loses 2 electrons to become Mg2+. This means it is oxidized. Copper gains 2 electrons to go from copper 2+ to copper metal. This means it is reduced. Simple ionic compounds are the easiest to work the oxidation number out for. Sodium, Na, is in group 1, so always reacts by losing only 1 electron to form Na+. This means that in the compound NaCl, sodium has an oxidation state of +1. All compounds are neutral, so the chloride here must be Cl-, or we say it has an oxidation state of -1. It is a little more complicated for covalent compounds, as electrons are shared rather than transferred. However, we can still state what we call a formal oxidation number. For example, in water, H2O, the oxygen is very much more electronegative, so we say it has an oxidation number of -2. It is sharing 2 electrons. And as the compound overall has to add up to 0, that means that H must be +1. Another example is SO2, sulfur dioxide. Oxygen is again more electronegative than sulfur. It shares 2 electrons, so therefore oxygen must be -2. Sulfur is less electronegative, so must have an oxidation state of +4 to balance out the 2 oxygens, so the compound as a whole is neutral. Okay, so here are some rules. First of all, elements are always 0. They have neither lost nor gained electrons. So, in compounds, group 1 metals are always +1. This is because they all have 1 electron in their outer shell, so they all react by losing 1 electron. Group 2 electrons always +2 for the same reason. They all have 2 electrons in their outer shell, so they all react to get to an oxidation number of +2. Aluminium +3 for the same reasons. Fluorine is the most electronegative element and has 1 space in its outer shell, so is always -1 in a compound. Now, we get to the slightly more complicated examples here. Hydrogen is very nearly always +1. However, in some very rare unstable compounds, you can find it as -1. These compounds are called hydrides. Oxygen, again, very nearly always -2. It is very electronegative. However, if it forms a compound with fluorine, it can go positive. OF2 is an example where oxygen is in oxidation state +2. It can also be found as a -1 oxidation state, but only really in peroxide, which is hydrogen peroxide, H2O2. Okay, so what I'd like you to do now is pause the video and have a go at working out the oxidation numbers for all the elements in the compounds below. I'll go through them one by one so you can check yourself after you've had a go. Okay, hydrogen nearly always has oxidation number of +1. Nitrogen is more electronegative than hydrogen, sharing 3 electrons, so it has an oxidation number of -3 to balance. Okay, so the next compound, hydrogen nearly always +1, oxygen pretty much always -2. So, in order to balance out, nitrogen must be +5. The next compound is quite similar. Hydrogen +1, oxygen -2. there are 4 oxygens in total and 2 hydrogens, which in total adds up to 4 times 2, 8 minuses, 2 pluses, which means we need 6 pluses from somewhere to balance, which has to be from the sulfur. So we say sulfur in sulfuric acid has an oxidation number of +6. The next compound looks almost identical but has 1 less oxygen. Hydrogen has an oxidation state of +1, oxygen -2 again, but as we only have 3, we only need sulfur to have oxidation number of +4 in order to balance it out. So we say that sulfur here has an oxidation number of +4. The last one, potassium dichromate. Potassium's in group 1, so is always +1. Oxygen -2. Now, chromium is a transition element, and they have quite a variety of possible oxidation numbers, so we've got to work this one out. There are 7 oxygens. 7 times -2 is -14. There are 2 +1s from the potassium, which gives us -12 overall. As there are 2 chromiums, that means each chromium must be +6 in order to balance the compound out. So we say this chromate ion has chromium in oxidation number +6. Many reactions are redox reactions, where reduction and oxidation take place in the same reaction. To work out what is oxidised and what is reduced, you first need to work out the oxidation number for each element in the species in the reaction. First, elements are always 0, which means in this particular case magnesium and hydrogen are both 0. Then we'll look at this and we say group 2 elements in compounds are always +2. So the magnesium in magnesium hydroxide must have an oxidation number of +2. The oxygen is -2 and the hydrogen is +1 when it's in a compound. So here the oxygen doesn't change. The hydrogen doesn't change, but the magnesium goes from 0 to +2. It has lost electrons, so is oxidised. Hydrogen here goes from +1 to 0. It has gained electrons, so is reduced. Note here that not every hydrogen has changed. We can ignore the ones that don't. Just the same as we ignore the oxygen that doesn't change, we can ignore the hydrogens that don't change as well. So, have a go at this yourself. Pause the video and work out what the oxidation state of each element is here, therefore what is oxidised and what is reduced. Okay, so here we have magnesium with hydrochloric acid. Again, the elements are always 0, so hydrogen and magnesium are 0. Hydrogen in a compound is +1. Magnesium is in group 2, so is always +2. Chloride is -1 in hydrochloric acid and in magnesium chloride. So the chlorine hasn't changed, but the magnesium has gone from 0 to +2, so it's oxidised. The hydrogen has gone from +1 to 0, so it is reduced. Another example is this reaction. Again, have a go, pause the video and have a go at doing it yourself. Try to work out what is oxidised and what is reduced. Okay, so the chlorine here, the chloride, is -1 on both sides. This means that the copper starts as +1. In the products we have elemental copper on its own, which must be 0. So the other copper in CuCl2 must be +2 to balance out the 2 chloride minuses. This means the copper goes from +1 to +2, but it also goes from +1 to 0, which means the same element, copper, is both oxidised and reduced. This sort of reaction is called a disproportionation reaction. Okay, last thing we need to do is naming. You need to know that the positive ion goes first, and if it is an element, then its name doesn't need to change. The negative ion comes after. If it ends in "ide", like chloride, then it is just the element on its own. If it ends in "ate", then it is the molecular ion made with oxygen, and the oxidation state of the element will often need to be stated. For example, NaCl, sodium chloride. Na on its own doesn't change, is positive, and chloride is just Cl-. For transition elements, for example, iron 3 chloride here, just saying iron chloride isn't enough, and that's because iron can have more than one oxidation state, and this is true of many other elements. In this case, there are 3 chlorides, so we know that the iron here must be 3+. This means the iron is in oxidation state 3, and we put this in Roman numerals after its name to say that that's what we mean. We mean iron 3 chloride. If you have an 8, then you have an oxoanion, and this example here is sodium nitrate. As you can see, Na is Na+, so goes at the front. NO3- is nitrate because it's got nitrogen and it's got oxygen, and we say it's nitrate V for 5, and that's because there are 6 minuses from the oxygen but only 1 minus overall, as the formula of this ion is NO3-. This means there must be 5 pluses from the nitrogen. So we state that again in a Roman numeral to mean it is nitrate 5, and that is the proper name for NO3-. When you see a compound with H+, it is very nearly always an acid. In this case, we've got H2SO4. You have SO4 2-, which is the oxoanion, and 2 H pluses. This is called sulfuric, Vi, meaning 6, acid, and that's because we have to state that the sulfur is in oxidation state +6, which you can work out from the 8 minuses from the oxygens and the 2 pluses from the hydrogens. Okay, so you need to know the names and formula of the following ions: NO3-, SO4 2-, CO3 2-, OH-, NH4+, and HCO3. Okay, so it might be a good idea again to pause the video and see if you can write down the names of all those ions. Don't worry if you can't at this stage, you can just go back and try again if you haven't. Okay, so the names of these ions are, to start with, nitrate 5. This is the one we already looked at. This is because nitrogen is in oxidation state +5. The next one is sulfate, Vi, meaning 6, as sulfur is in oxidation state +6. The next one is just carbonate, and this is because carbon only forms the carbonate ion. You don't see it in any other oxidation state like this. NH4+ is the ammonium cation, and HCO3 is the hydrogen carbonate anion. This is one that is present in your blood. So, you need to be able to write formulae for compounds formed between these ions and other anions and cations that you may be given.